The world around us is constantly in motion. It might be machines or racing cars, or it might be something like me flying a hang glider or jumping out of a perfectly good aircraft. Hi, I'm Dr. Wayne Whiteman, and I teach mechanical engineering at Georgia Tech in Atlanta, Georgia. Earlier in my career, I served as a professor at the United States Military Academy at West Point. This course is an exciting look at the study of bodies in motion as applied to engineering systems and structures. There are many examples of dynamic systems and structures that we encounter in everyday life. In fact, in this course, you'll even learn what is meant by the sweet spot so that you can hit a golf ball or a baseball further. In my earlier courses in engineering mechanics, we studied static equilibrium of a real-world system like a cherry picker truck to make sure it would not tip over. In this course, we'll study the motion of systems under various loading conditions. The format of the course will be 47 modules, approximately 10 minutes each, over a period of 7 weeks. There will be a graded quiz each week. To be successful in the course, you will need to have mastered basic engineering mechanics concepts and to have successfully completed my courses entitled An Introduction to Engineering Mechanics and Applications in Engineering Mechanics. We will apply many of the engineering fundamentals learned in those classes, and you will need those skills before attempting this course. My hope is that this course will change the way you look at the world around you. We will have been successful if this course sparks an interest in you to explore engineering systems that you encounter on a daily basis and look at them through the eyes of an engineer. So that was the introduction video for the course. Now let's look at the specifics of what we're going to study in the class. Here are the learning outcomes for Module 1. First, we're going to describe the relationship of this topic of engineering dynamics as part of the overall study of engineering mechanics. And we're going to list the major topics in the course. So, engineering mechanics or engineering science takes the fundamentals of math, physics, and basic science, or how the physical world works, and transforms it to the fields of engineering. That might be mechanical engineering, civil or aerospace engineering, material science engineering. All of these are applications of science to fulfill a human need. So engineering mechanics is sort of a wiring chart. We're looking at rigid bodies. This was the case in the 2 earlier courses I taught, which were on statics. And now we're going to look at bodies in motion or dynamics. And we break dynamics into 2 major categories as well. Kinematics, where we study the geometrical aspects of the motion or the space-time relationships. We look at things like position, velocity, acceleration, and time. And then once we are able to describe the motion geometrically, we look at the kinetics, which relates the forces acting on a body to the actual motion of that body. In later courses, we can also study deformable bodies. Those courses are often called mechanics of materials or strength of materials, which apply many of the fundamentals that we learned in my earlier courses and we'll learn in this course. So, here are the major topics in the course. The first portion of the course will start with particles and systems of particles. In kinematics, we'll look at rectilinear motion and coordinate systems for describing the motion. And in the kinetics portion, we'll use the principles of Newton's laws and Euler's laws, work energy principles, and conservation of momentum and impact to study the motion of particles and systems of particles. And then in the second part of the course, we'll extend that to the motion of bodies in rigid planar two-dimensional motion. And there we'll look at kinematics again. We'll study relative velocity and relative acceleration. We'll study the topic of instantaneous center of zero velocity, and we'll look at velocity and accelerations with 2 different reference frames. And then we'll take those same basic principles that we used in kinetics for particles and systems of particles, extend them again to two-dimensional planar motion, and that will be Newton-Euler equations, work energy principle again, and impulse momentum. So we've got a lot to do, so I'm excited to get started, and we'll see you in the next module.